In relative velocity problems, it's important to read the questions carefully. It's important to ask yourself which of these vectors is the resultant. If you cannot answer this clearly, then you need to maybe go back and reread the question and try to draw out some arrows to identify which of the vectors described would be the resultant. This is important because when we're drawing arrows, we have talked about drawing arrows tail to tip, so like this. That, however, is only done for vector components. So where the tip of that arrow met, the tail of the other arrow lined up, and they basically follow each other in a seamless line. Resultant arrows, though, are always drawn from the start point of those components and drawn to where those components ended. So the overall result of both those together. So resultant arrows are not drawn tail to tip. They are drawn from the origin of the component arrows to where they finish. Now, usually in relative velocity problems, we are going to ask you for the motion relative to Earth. So relative to Earth, it may not be worded that way. It may instead be asked in a manner such as the person standing on shore, how would they see this boat move? Well, the person on shore is assumed to be stationary and not moving. Therefore, they really are kind of the Earth, the non-moving stationary Earth. Or if it's a plain question, maybe it's somebody stationary on the ground. For these questions, you're going to see more than a couple variations, but I'll go over the main variations. One of the main variations outright states the resultant in terms of it's what is desired. So they may state this as the boat or plane's destination is due north or due south or due east or due west of its launch point. So in this case, they're telling you what the overall result is that they want to see of travel. So in this case, we'll say maybe the overall result is a due north. Now, this is the result because it's saying that if you were basically in that plane and you left somewhere, you would be flying directly and landing somewhere directly north of you. Okay. Now, with these questions, there's always usually a wind in the case of planes or a current in the case of boats or somebody swimming. So there's usually a description of saying, okay, a crosswind or a wind of, let's just give this maybe 15 meters per second to the east. And somewhere in the question it stated that the pilot launches and desires to land directly north of their launch point. Well, if a wind is going to the east, and I'd recommend you then draw out an arrow to the east so you can think about what you have to take account of. So a wind of 15 meters per second to the east. So we have an arrow that looks like that. And then very often the question will ask, in order to land directly north of their starting point, what must the plane's heading be? When we ask for a heading, this is the direction that the pilot or the captain of the boat is going to point the vessel. So at what direction, angle and direction does the pilot or captain have to point the vessel? So we have a couple things we're now going to be thinking about. We know that the outcome desired is what we've already drawn. It's directly north from where they left. So that's our resultant. But we have a couple other components to think about. One is the wind that's already been described to the east. And now we're aware of what the other component is. The other component is going to be the plane's heading. So which way does the plane need to point? This way, this way. There can be a whole bunch of combinations. Okay. Or maybe they just need to point directly north or directly south. So the way to determine this is I will take my resultant, and since this is what I know I need, right? I've already done it. There's my resultant. And now I'm going to look at the components. So one of my components is going to be this east wind. So if I draw this east arrow, just so I can grab it, make it a little bit easier to show you this part. This is a component arrow, and I need the components to end where my resultant ends. So if I put it on this side, that would be tail to tip. We do not want that for components and a resultant. we need our components to end at that resultant. So putting on that side works much better. At that point, I can then think, well, where does this boat have to aim? And so if you look at all the variety of directions down here that we can have our boat aim, it starts to become clear that if your components have to start at where your resultant starts, and the components have to meet up tip to tail, there's only one real way to have that plane start. So let's check. Do our components adhere to the tip to tail? They do. Is our resultant drawn from where the components began to where the components end? Yes, it does. That means we're now ready to calculate our heading, which will be the angle from whatever directional line you choose. So I could quote it from the north, I could quote it from the west. Okay, whichever you choose is just fine. Now I do have values to put on these arrows. The wind was 15 meters per second to the east, so I'll label it as 15. Okay, and the only thing I did not give you in this question yet is the velocity that the plane is capable of. So if the question states the plane's motor capable of 756 kilometers per hour, well, where does this number go? So you might think, well, because the plane is actually going this way, overall, that's where it goes. But no, where is the pilot actually had to point that motor? The pilot has actually had to point the motor along this heading line to take account of the fact that as they move that way, the wind's going to push them back. They try to move that way, the wind pushes them back. They try to move that way, the wind pushes them back, and so on. So this is the line along which the motor acts, and that is the line along which we'll get the value then of the motor. In this situation, you now see that we have a right angle triangle. We have two of our sides. We can now solve using trigonometry for this angle. A brief note here, our units do not match, so we will have to convert this to meters per second, or we could convert this to kilometers per hour before we proceed.